All right, good morning, ladies and gentlemen. Today we're going to talk about elimination, which is out of the three solving systems ways, is my favorite to do these. Uh, so I think this is a super useful way. It works for everything, which is nice, and I think sometimes it has a little front work to do, but once you get it set up correctly, I think it kind of falls the quickest and easiest stuff. Um, we'll go through that. We'll talk about elimination, and then we will be moving on to what happens when we see like three equations with three unknowns and a couple different things. So today is your last day of review from uh, Algebra 1. So this, once again, was taught to you in Algebra 1. Hopefully you remember it, but either way, we'll go through it and you'll hopefully have some success with it. So in general, what is elimination? Well, elimination is the idea that we can eliminate a specific variable by intentionally adding our two equations together in a specific way. So in general, we can add equations together and we should get something that's still true, right? If I had, well, we'll do it just without variables. This is an equation and it's a true equation. It's a true statement, right? It's equal. And let's say 5 is equal to 5. That's true as well. Yeah, so those are both true. We know that. If you just add these together, what happens? Well, that's 17 is equal to 17. That's also true, right? So I can take two equations, I can add them together as long as they were true to start, which well, we assume when we see equations. That's how math works, right? So if I add those together, the result should be the same as well. So what we can do is take our two equations that have x's and y's, and if we set them up correctly and we add them together, there's a way to eliminate a specific variable to make sure to then solve for the other one. So if you look here, this is our first example, and this is nice because you'll notice right here, I have a positive 4x and a negative 4x. So this one is set up for us because these two are ready to eliminate each other. If we added these two things together right there in red, we would get 0. They'd go away, which is great. And that's going to be the plan for all of these. We're going to need one positive and one negative versions of our variable. We do need to make sure everything's lined up. So our x's are on the left here, our y's are in the middle, equals, and then our constants on the right. So these are all lined up. We'll need to make sure we do that every time. But these ones are just ready to go. So let's see what happens if I try and add these things together. And we're adding, so anytime we're adding, we're combining like terms, right? So these cancel out. Great. We just eliminated x's. There are no more x's now because we eliminated them. 9y plus 7y and 5 plus 11. You're adding everywhere, right? So we're adding those together. Those two canceled out. 9 and 7 is 16. 5 and 11 is 16. Cool. So that's why I kind of like these, because once we do that, well, shoot, it's just a y now, and our equation's pretty easy to solve. If I divide by 16, y is equal to 1. Great. But remember, we're not done. We can never be done until we find the point. We're looking for our point. Where do these two lines intersect? It's a point xy. So we need to go take this and plug it in for either of our two equations to get our x value. It doesn't matter where you put it in. I'll go up and put it in right here, and it'll say make sure you're using parentheses anytime you plug something in for a variable. So parentheses 1. And then solve that equation for your second variable, x. So 9 times 1 is just 9. I'm not going to rewrite that in a whole step. I'm going to subtract 9. And divide by 4. So we have an x value of -1, y value of 1. So our final answer is -1, 1. Remember, you need an x, y for every single one of these points. So that's a review on elimination. That was ideal because they were lined up. When we added them, they canceled each other out. So that was about as nice as elimination can get. So we might have to do some stuff to make that happen. But let's check example number 2. Okay, so example number 2, it says x minus y is equal to 10, and then on the bottom I have 3x plus y is equal to 18. Great. So if we look here, if I added x and 3x, well, I'd get 4x. That's not that cool. Okay, interesting. What if I added here negative y and a positive y? Oh, nice. So a negative y and a positive y, right? Those, if I added together, would cancel out, which is great. So it doesn't have to be the x's. It doesn't have to be the y's. It can be either one here. So we'll do this again quick. These are also set up to go, so we'll add it in here. X plus 3x is 4x. Negative y plus a positive y is gone. 0. We could write plus 0, right? That's kind of what's happening. This is 0y, but nobody ever writes that because it's 0 times anything. Anything that y would be 0, and then we're just writing an extra chunk that we don't really need. So we don't write zeros in there. So is equal to 10 plus 18 is 28. Great. Well, okay, nice. So we'll just divide by 4 on both sides and we'll get x. Beautiful. Okay. Cool. So then I need to go find y. I can plug it in anywhere. It doesn't really matter. The top equation looks nice and easy, so maybe I'll plug it in there. If you plug it into the second equation, you should get the same answer, right? Because x equals 7 is supposed to be the x value where we get the same y value for both of these equations. That's what it says, right? This is the intersection point. So if I know this x value, the y value for both of them should be the same. So it shouldn't matter which one you plug it in for. Pick either one. In this case, I'll pick the top one again. I didn't put it in parentheses. That's 7 because there's nothing being multiplied by it, so it didn't necessarily need them. And I will do this in 2 steps. Subtract 7 on both sides. Negative y is equal to 3. But I don't want negative y. I need a positive y. Anytime you have negative variable, to get rid of that, we'll just divide by negative 1. Divide by negative 1. That's really what's here, right? This is negative 1. We don't write the 1 because it's implied, but we will divide by negative 1. So we get y equals negative 3. Cool. So our final answer is the 0.7, negative 3. Make sure you're writing it like this. It's a point. We're looking for that point, specifically on the x, y coordinate plane. We're looking for that point. We need to write it in parentheses with a comma in between, right? X value, then y value, every time. Okay, so that's example 2 where we just added them together. They canceled out, and we got some beautiful stuff. Fairly straightforward, pretty easy. Nailed it. Okay, now, if we look at this one, well, 3x and 3x, isn't that right? 3x and 3x. If I added those together, I'd get 6x. Okay, not quite, not really what we're looking for. Negative 10y and negative 9y is negative 19y. That's not that cool either. Okay, weird. Okay, so now I have to sit here and be like, well, I need to add these two things together, but right now nothing will eliminate. How do we handle that? Well, to handle that, we get to go through and we can say, well, what if I just manipulated one of these equations a little bit? What if I did something to one of these equations so that when I added them, they would eliminate? And that's going to be the plan. So oftentimes it won't be like those first two examples where things are just magically lined up, ready to be added together, looking beautiful, right? That's not really terribly realistic for most of our problems. Most of our problems will maybe look something like this, where it's like, wait, 3x and 3x, those are dang close, right? I can do something to that, right, to get them that way. All I really need is one of those threes to be negative. Well, make it happen. We can do that, right? We can manipulate things in math to make it work. So what we're going to do is we're going to multiply. We need to multiply. That's how we're going to do it, right? We're going to do multiplication. That's going to be how we do this. So we need to multiply one of those two equations by something so that my x's cancel out. Okay? So you could pick either the top or the bottom to do this too. I'll just do it to the top. If I multiply, well, what do I want to multiply 3 by to get to a negative 3? Well, just a negative 1. We don't need to change the 3 part. We just need 1 to be negative. So I'm going to multiply by negative 1. But if I do it to one of my things in my equation, I need to do it to everything in my equation, including both sides. Okay, so every single time that you multiply by something in an equation, you're doing it to every single piece on both sides. Okay, so if I multiply by -1, I'll write my new equation in blue underneath. -3x plus 10, -1 times -10 is negative, or is positive 10 now. And 14 times -1 is -14. Okay, so this equation's gone. We don't need him anymore. He's out of here. And now you'll notice, look at this. Beautiful. Now 3x and -3x, those are matched up. Now if we added these two things together, right, we would actually eliminate my x value. So that's the whole plan. We might need to multiply it some. Okay. So we'll finish this out. I will add here. If you add 3x and -3x, eliminates out, it's gone. 0, but we don't write 0. 9, -9y plus 10y. Whoa, that's just one y, or remember y. Beautiful. And 15 minus 14, or plus -14, same thing, right, is 1. Whew, nice. Ah, that one's easier, right? We're already done. We didn't even have to do extra steps. How nice is that? So then we'll plug our y in. You can plug it in once again anywhere. You can even plug it into the blue equation that I manipulated. It doesn't really matter. It should work everywhere, as long as you're doing your math right. We'll plug it in here. Why not? 3x minus 9 times, 9 times 1 is equal to 15. So I just plugged my 1 in for y in that equation. To solve this, we'll do the same thing we always do. Okay, -9 times 1 is just going to be -9. So once again, I'm not going to write that stuff out just for the interest of space. So I will have, I will need to add 9 to both sides. If I add 9 to both sides here, these cancel out. I'm up to 3x is equal to 15 plus 19 is 24. And if I divide my final answer here by 3, x equals 8. So my final answer is the coordinate point 8, 1. Beautiful. Okay, so you might have to do some manipulation. I think we're going to go through 2 more examples in which you're going to need to do some manipulation and show you kind of a couple other things that happen here. Okay. But maybe a good point to pause the video and say, did I really understand those last 3 examples? Because those ones are the most straightforward ones. The whole plan is to add 2 equations together and eliminate one. This one we manipulated things a little bit. So those first 2 equations were made for us. This one we had to match up our variables right so that they would eliminate. And then the next 2 are going to be even more work to get there. But nothing terribly difficult. We can handle it all. So this one. Oh no, I'm gonna skip that one. We're going here. Okay, so this one on the other hand. Okay. So this one, we need to get, well, let's look here. I got 3x and 5x. If I added those together, I would get 8x. I would not be able to eliminate those, but they are lined up good. Okay. 3y and 4y, add those together. And I get 7y. That's not great for us either, right? And honestly, getting 3 and 5 together isn't that cute, and getting 3 and 4 together isn't that easy either. So, like, what am I supposed to do? Well, you might have to adjust both equations. Okay, so last time all I had to do was multiply by a -1. Sometimes you'll have to multiply by maybe a +2 just to get a 4 to match a 2 or something like that. Okay, but in this case, we're going to have to do it twice. We're going to have to do it twice. So here's the thing. We can either get 3 and 5 to their least common multiple, which is 15. So we could meet at 15 for our x's, make sure one's positive and one's negative. Or we could multiply, if we were trying to get our y's eliminated, we could do 3 and 4. We could get their least common multiple, which is 12. So we could try and get our y's to be 12, one positive, one negative, and then eliminate. So let's go with 12, I guess. It's a smaller number, and we just eliminated x last time. So why don't we go through and eliminate here? Okay, so I need one of my equations, let's say the top one here, okay, to be 12. I'm once again trying to match these 2 up so that they are the same variable, one positive, one negative. So let's go with the top To get that to 12, I'm going to multiply the top by 4. And if I do it on the left, I got to do it on the right. So if I'm multiplying these in, once again, you got to distribute it everywhere. Every single piece is multiplied. So I have 12x plus 12x plus 12y is equal to 36. And now the bottom equation, we need our y to be 12, but not just 12. We need to be a negative 12 so that when we add these together, we get one to be positive, one to be negative, and they cancel out, right? So I will multiply the bottom equation by -3. Not just 3, but -3. So that when I do this, I'll have -15x minus 12y. That's the point we needed, right? 12y and -12y. That's the good stuff. Is equal to -30. Okay. So that one was definitely harder to get these to match up, but we did it, right? If you look here now, I have a 12y and a -12y. Good. And those are matched up and we'll eliminate now. Okay, so it was a little bit more work there just to make sure, but really we're just finding least common multiples and and having a meet there, right? So I had those both meet at 12. Once again, you could have just as easily got your x's to meet at 15. There's even another way you could have done it, but those are probably the two quickest and most easy to think of ways. So I will add these together. If I do, 12x plus -15x is -3x, and 12 plus -12 goes away. And I'm left with 6 on the right. 36 plus -30 is 6. Great. So now this is an easy equation. We'll solve this out. X is equal to -2. Great. Well, now we just need to plug this in. There's a bunch of different places you can plug it in. Either of the black equations, the red equation, the green equation, all of it would work. I'll go back up and plug it into one of the black equations just because the numbers are a little smaller. Let's do here. So I plug it back into the original equation. That's always a good bet. And if I multiply this out, -6 plus 3y is equal to 9. I'll get that 6 out of there. And I'll finally divide by. Once again, your final answer needs to be these 2 points, excuse me, these x and y together, -2. Awesome. Okay, so that one was different because we needed to meet somewhere that wasn't really convenient for either of them, so we multiplied both equations, but it's just as easy as multiplying one equation. It's no different, so that's great. All right, we have time for just one more problem. It is the hardest version of all of this, so we'll go do one more. The hardest thing that can really happen for you. Now you'll notice, hey, these guys aren't even lined up, right? These guys aren't even lined up, and that sucks. We need them lined up, otherwise when we eliminate, things won't add together right. They have to be on the correct side, otherwise we're in bad shape. We want it to look the exact same. That's going to be the easiest for us to get. So it doesn't matter what they look like. Frankly, we could move the bottom equation, that y, over to the right side so that it looked like the top equation, or we could move the top equation's y over to the left side so it looked like the bottom equation. It doesn't really matter. They don't have to be. So if you look back at all of these had x, then y, then equals the number, right? You don't need that. That's okay. It could all look like the bottom equation here, or I guess the top equation here. That'd be fine too. So don't act like you need to get it in what's called standard form. That's what the last couple have been in. It doesn't have to say x, then y, then equals number, right? It can say x equals y plus or minus number. That's fine too, like that top equation. But in the interest of making things look the same. I'm essentially going to subtract 4y from that top equation. I'm just going to move that y over so it looks like the bottom equation. I'm going to start with that. Minus 4y minus 4y. And my top equation will become 2x minus 4y is equal to 18. Okay, so I just moved that y over on that top equation so that now my top equation looks like my bottom equation. So this is now gone. We don't have to worry about that anymore. That is all gone. We're just worried about negative 5x minus 6y is equal to 3, and 12x minus 4y is equal to 18. Okay, but I said this was the hardest one because once again, I can't get 2 and 5 to be that similar. I can't get 6 and 4 to be that similar, so we're going to have to meet somewhere else. I can't just bring 2 to 5. I can't just bring 4 to 6, right? We're going to have to meet somewhere else. Your two options seem to be we can get 5x and 2x both to be 10x's. That'd be nice. Those would then cancel out. Or I could get 6y and 4y to be something. There's a couple different options. 12 is the least common multiple. Or you could go up to 24. It doesn't really matter. I don't suggest going all the way up there. Let's do the x's to 10x and negative 10x because it looks nice because one's positive and one's negative already, so all I have to do is the number. So that's kind of nice. Not that it really matters because we're multiplying them both anyway. So to get the top to be a 10, I'm going to multiply by 2. And if I do it on top, I got to do it to the left as well, or excuse me, to the right side. Both sides of both equations, or every number in both sides of my equation. So 2 times negative 5x is negative 10x. 2 times negative 6 is negative 12y. 2 times 3 is a positive 6. Wonderful. So I need that blue equation now to have a positive 10x in the front, which means I'm going to multiply by 5. I do it everywhere. 5 times 2 is 10. Great, that's the plan. Right now our x's will eliminate. 5 times negative 4 is negative 20. And 5 times 18, 50 plus 40 is 90. 50 plus 40 is 90. This is true. Okay. All right. So we will then add these two things together. Why does this look like it's not going to work? Oh, no, it does. That's nice. Okay. So if I cancel these out, because that's our elimination step, we have negative 12y plus negative 20y, which is negative 32y, is equal to 6 plus 90 is 96, right? And if I divide here, so your numbers might get a little big on you, but it all should work out. If I divide here negative 32 on both sides, we get y equals 96 divided by 32 is a negative 3. Negative 3. Great. Okay, so that was definitely a little bit more complicated, but remember the whole plan is one, make sure they match up vertically, okay, which we did. We moved that y over in that first equation. Then we make sure they match up numerically, one positive, one negative, so when we add them together, something cancels. And we solve for y. Don't forget to go back and plug it into one of these equations. You can do it just about anywhere. I will do it. Let's see. Let's go back and plug it into here. Why not? Why not? We'll just plug it back in there. I already crossed off the top. Maybe the top's even easier, but that's fine. We'll plug it in there. It says 2x minus 4 times y. Y was negative 3 is equal to 18. Cool. And solve. Solving part should be pretty quick. Negative 4 times negative 3 makes 2x plus 12. And divide 3 and -3, so your final answer is 3, -3, done. Okay. Definitely the hardest problem out here that we did today, just because you got to move it first, then you got to match them up, then you got to make them be the same, positive and negative. So then we add them together, one eliminates, solve for a variable, and plug in the last one. Okay, so that is elimination. Hopefully that rings some bells. Personally, my favorite, I think once you do the little bit of work at the beginning to make sure things match up and actually eliminate, it ends up going really quickly. So this is my favorite. Find the one you like. I would like you to do elimination all day today, but then you can find the one that you like and are most successful with to solve for the rest of it. So let me know if you have any questions. Good stuff.